Okay, so today we're going to be talking about friction. Friction is a force that opposes the direction of motion. So when that happens, there's an actual equation we can use to calculate it. Friction force is equal to mu, which is the coefficient of friction. It's kind of like a lowercase u with a little booger hanging off the front, times the normal force of an object. What is the coefficient of friction? It's the ratio, all right, between the force necessary to move one surface horizontally over another and the pressure between the two surfaces, and it's represented by the symbol mu. Okay, FF is our friction force, coefficient of friction, which has no unit, and our normal force. So friction force and normal force both are in newtons. If you divide newtons by newtons, the units will cancel out, which is why this dude has no unit. Now, a lot of times you're going to be given mass in a problem. So how do I find Fn? Well, Fg and Fn are going to be equal on flat surfaces. Those are the problems that we're dealing with. So Fg is going to equal m times g. All right, remember that g, we are using the value of 10. Coefficient of friction can be two different things. It can be the coefficient of static friction or the kinetic friction. Static friction force, all right, is basically between two objects that are not moving. And to get it to start moving, your applied force needs to be greater than the static friction force. And then once it's moving, then, all right, the overall friction kind of drops. The friction force drops because once it's moving, all right, the coefficient of kinetic friction is less than static friction. So, kind of just showing, all right, this graph here, all right, and then the simulation. So if I push, if we know the mass of this object, okay, we can calculate exactly how much the friction force is, the static friction force. We know the coefficient of static friction. We know the mass, so mass times gravity times the coefficient of static friction. Okay, this dude has a maximum static friction force of 490 newtons. So if I push with this much force, the friction force is 400. If I push with 178.25, that's the friction force as well, which is kind of showing here like, all right, the applied force and the static friction force will be equal all the way up until you get to the maximum static friction force. If you go just above that number, it now will start to move and it becomes kinetic friction force, and that is less than the static friction force. So you can see that drop in this simulation. So the maximum force that we can go, all right, is 490. So if I type in 490 and push, you push at that exact thing, it is not going to move. Now if we go just above that, we go 490.01, you can see that the friction force size dropped, okay? And since the applied force does not change, since the applied force didn't change, that provides us a net force, which causes the object to accelerate. Okay, so now getting into our problems that we're going to be dealing with. In our problems, I want to make sure you guys that have this worksheet, okay, for the problems that we are going to be doing, these are going to be your test type of problems. You're going to have four forces for all of these. So your four forces are going to be Fg, which we're always going to draw down, your normal force, which we're going to draw up, your applied force. For these problems, we're always going to say they're going to the right, just kind of give us some consistency here, and friction force, which we will make drawn to the left. A couple other notes that you would want to make sure you have and you know is that the Fg and the normal force are going to be equal to each other. So to find Fg, right, the weight of the object is equal to its mass times gravity, and we are using the value of 10 for g. Okay, so we have all of those. So now we can kind of start doing this. So to get the full value of all of this, you have to label all the work, all right, write down our equations, substitute the values, get their answers, and then we have to have these four forces drawn onto here and correctly labeled. So I'll give you this first 4 points are the same for these problems. You're given mass in all of them. So the first thing we're going to do is take weight, mass times gravity. The mass of this is 12.5. Gravity is 10. This gives us 125 newtons. And we always draw Fg down. And Fn is going to go up. Fg and Fn are going to be the same, especially on a flat surface. So all of the problems that we're dealing with are on a flat surface. So those two are equal. I'm going to show that they're equal. And these is how I would score it. Writing out the equation, substituting in values, getting the correct answer would be your first and second point. Drawing in your vectors with their correct labels, okay, would be our third and fourth point. So this would be point 1, point 2, point 3, and point 4. They wanted us to find the friction force. They gave us the mass and coefficient. Well, we had to find the normal force first, so we can then use that. So friction is equal to, all right, your triangle for it down here, how the triangles work, cover up the value that you're looking for. Friction force is equal to the coefficient times the normal force. If you're looking for the coefficient, it would be the friction force divided by the normal force. And then our Newton's second law triangle, if you know mass and acceleration, you can multiply them to find net force. If you're asked to find acceleration, you do the net force over the mass. So we're looking for friction force, covered up mu times normal force. Now we were given our coefficient mu of 0.55, but let's write out the full equation. And then type in our values. Okay, 0.55 times our normal force of 125, and that's going to give us 68.75 newtons. This will be your fifth point. Show the equation, put the numbers in, get the answer as your sixth point. Now, like I said, up top, we're always going to have our friction force pointing to the left, so let's draw this thing into the left. And now we have our seventh point. And that's going to be usually the main setup for the first four, most of those problems. Now, where do we go from here? They said if the block is being pulled by a 17 Newton force, what is the net force? So you may look at the equation and realize, okay, well, if I want net force, I cover that up. I do mass times acceleration. We have the mass. We don't have acceleration, so we can't do that. So this right here is another piece of information, this being pulled by a 17 Newton force. That is our applied force, which we're going to draw in to the right. And so that will be our eighth point, right? Drawing that in. And why is that important? Is now, because we didn't have the acceleration to go along with the mass to calculate it, now we can get the net force from our picture. All right, from our free body diagram. When the two opposing vectors, right, so guys going in the opposite direction, when they balance out, like Fg and Fn, which they will in all of the problems, okay, we can pretend like they're not there for a second. And now you have 68.75 to the left, 17 to the right. It becomes like a tug of war problem. So what we do is when you have forces in the opposite direction, we subtract. So we are going to subtract friction force and your applied force. So our F net is going to equal our 68.75 minus the applied force, which was 17, and this gives us a net force of 51.75 newtons, and the direction would wind up being to the left because the friction force was the larger side, larger magnitude. Right, that would be our ninth point. Ninth point, right, it's a step. Now the problem used to be just they gave you a mass, an applied force, and a coefficient of friction, and they just said find the acceleration. I broke it down to try and give you a little bit more steps to make it a little bit more, process based instead of just kind of being stuck and confused. Like I try to guide you, like, hey, well, what's the friction force, right? So you would need that to help us find the net force. How do we find the friction force? Well, you need the weight, mass times gravity gives us this. Draw it in down, normal force up. Now you know what the normal force is and the coefficient. Multiply them. That's how we get this guy. The applied force was given, so we draw that in. Subtract to get the net force, and now we can find acceleration by covering that up. F net over m. So we will now write that in. F net over m, you're going to get your 51.75 divided by 12.5, which is 14.14 meters per second squared, and it will be to the left. So showing the equation that you need and doing the substitutions, right? That's a point. Getting the correct value is a point. Remember, we need the correct unit and the correct direction. So this would be your 10th, 11th, 12th, and 13th point. All right. So the number 2 is done the same way. You have a 37 kilogram block. You have a coefficient of 0.65. So step 1, mass times gravity, get our weight. Draw in weight, draw in normal force. First 4 points, 100% the same. Now what you have normal force and the coefficient, friction force is coefficient of friction times the normal force, so I'm taking 0.65 times the normal force of 370, we get 240.5. That's your 6th point. Draw this in as your 7th point. The block is being pulled by a 48 Newton force. Draw that in. That's your 8th point. Net force they wanted. Net force, well, the top and bottom balance, so we're going to subtract these two guys. So 240.5 minus 48 gives us 192.5 newtons to the left. And then, once you have the net force, and we already knew the mass was 37, acceleration net force over mass, take your 192.5 divided by 37, you're going to get 5.20 meters per second squared, and the direction will be in the same direction as your net force. In this drawing here, in 3, they give us mass, they give us something else. All right, but first thing you can do is, with the mass, we can find Fg, m times g. We need this because I asked you guys to make sure we draw in all of our force vectors anyway. So 5 kilograms times gravity of 10, we're going to get our 50 kgs here. 50 newtons, and then we can draw Fg down, and our Fn going up, same value. They are equal. Now, they ask, what is the net force on the block? Well, when you see constant velocity, anytime you have constant velocity, the F net is 0. Why is that important? Because they told us this thing is being pulled, all right, across the horizontal surface by 25 newtons. So I always said for you guys to draw in your applied force to the right. So that is 25 newtons. And since the net force is 0, everything must balance. And so we will have to have our friction force going in the opposite direction, and that will be the same number, 25 newtons. And those two are equal because of that. So here, similarly, you have your first point, second point, third point, fourth point. You can draw this dude in here as our 5th point, knowing that the net force is 0. This dude going over here as our 6th point. They ask you to add what is the friction force. So again, that's super simple. We just rewrite that as 25 newtons. Okay, for our 7th point. Okay, why is that? Because, again, at constant velocity, all forces must balance. So we didn't actually need to do any math for that one. And now they want the coefficient of friction. So coefficient of friction, when we cover that up, it's friction force divided by the normal force. So mu, coefficient of friction, FF over Fn. And so what we get left with is our 25 over 50, and we get 0.5, and there is no unit for the coefficient. So this would wind up being our 8th and 9th point. And for the last one, similar, mass was given, weight, all right, mg times 10, you get weight down. Draw it down as your 3rd point, normal force up as your 4th point. Friction force, your 5 and 6, coefficient times normal force. So you're taking your coefficient times the normal force of 4,000, you get 2,800. We draw friction to the left as our 7th point. Now, they wanted Fnet, but they never told us what the applied force was originally. That was blank, right? That was blank. So what did we do? We were also given the acceleration. So with the equation for net force, mass times acceleration, we took the mass of 400 times 0.55, and we got 220 newtons to the right because the acceleration was to the right. Once you know that, to find the missing value, okay, this is basically saying that the right force needs to be 220 greater than the left side. So with that, you would add friction force plus the net force, which would give us our applied force. So we took this 220 and added it to the 2,800 to get us a value of 320 newtons. And we are going to then add it here for our total of our 12th point.